Okay, so we start with number 5. So Carlo's saving for college and wants $98,000 when he gets out of high school. He currently has $46,000 from an inheritance in an account at an interest rate of 6.3%. How long will he have to have the money in this account to earn what he needs for college? 5 was a lot easier than 4 because 4 was about compounding continuously. 5, it looks like it's just compounded annually. So for number 5, the equation we're going to use or 5, I should say, the thinking we're going to go with is he wants to end with 98,000. He's starting with 46,000. And every year he gets to really take his balance and multiply it by and we're just curious to know how many years is that going to take. So we'll take this equation and we will go solve it. So things that I notice after I built this model, the variable I'm trying to solve for is in the exponent position, which tells me I'm going to need to use logarithms to get access to that. I'm going to need to put both sides in a common base. I don't see 10 anywhere. I don't see e anywhere. So I'm going to go with base 10. First things first, though, I want to divide both sides by 46,000. So 98,000 over 46,000 is how much? 2.13? Okay. 2.130. Okay. Okay. So we've cleaned this up a little. Both sides are going to be put into base 10. Anybody know the exponent to put on 10 to get 2.130? Okay. So wait, log 2.130 is the exponent you put on 10 to make 130. So you'll notice what's highlighted in blue here. How is it related to what's highlighted in blue above it? Okay, good. Equal, the same. So on the right-hand side, I'd like to take 1.063 and put its equivalent in base 10. Ten to the what is 1.063. Okay. I want you to clean up the right-hand side before you get rid of the tens. So these two exponents, are they added or multiplied? So 10 to the t log 1.063. Okay. What do you do with the tens, Andrew? Okay. If both sides are equal and both sides are in base 10, then the exponents have to be equal. So you're right on with that. You can actually get rid of the tens at this point. Solve for t. T equals log of 2.130 divided by log of 1.063 And that is approximately... Point what? 0.3? Now I gotta remember, did we answer the prompt? It was... How long will we have to have that money in the account? roughly 12 and a half years. Or you could say 13 years, because if the interest is accumulated annually, we talked about not having access to those funds, not earning the interest until it sits in there for the whole year. Bree? This guy, okay. Okay. So if we had like x squared to the fifth, that would be x to the 10th. So I took this right-hand side and I said, well, that's really 10 to the t times log of 1.063. And the left-hand side remained the same. And then I think that was the point where Andrew said, hey, both sides are in base 10. You can set the exponents equal. So we got rid of them. Grant, you had your hand up. Okay. Humor me for a second, and we're gonna stick with this problem. We're gonna do 5 again, a little bit differently, just because it's gonna set you up better for 4. So what if the first decision wasn't to wasn't to divide both sides by 46,000? Is there a way to take this entire right-hand side and convert it so that it's 10 to a power? And, yep, you're shaking your head. Yes, there is. So, watch what happens here. 46,000 is 10 to the what? Okay. We have talked about how this guy gets rewritten. So blue will get rewritten as 10 to the what? Like that, right? Okay, nothing magical yet. Okay, and tell me if you're okay with this next step. Okay, are we okay with that? Okay. So if I were going to combine these, this would be 10. So how do I go about this exponent and this exponent? How should they get combined? Bree, before we answer that question, Bree, what's up? Oops. I think that the t right here was with the log 1.063. And guys, what Bree is doing, stopping and asking and going back, you need to be doing that too. I mean, if you're still looking at it and you have a question, you need to kind of take control of your learning and ask the question. So for some of you, it'll take you a while to develop that confidence. I hope you can work on that in here, but I promise you, you will be so much better off in all of your classes. Melina? Correct. You don't distribute it to the 10. It's just the base. Like if we had kind of this example right here. And the reason is x squared to the 5th is x squared 5 times. But yeah, so that 5 doesn't go to the x. It just applies to the exponent. We call this power to a power. So this was number 5 again. We said, well, what if you chose not to divide both sides by 46,000 to start? So it's possible to rewrite the right-hand side in base 10. So the right-hand side is really 10. What did you guys say these two were going to get combined with? Addition or multiplication? Addition. Okay. Both sides, common base. What can you do with the 10s? Yeah. Thank you, Andrew. Okay, you and your neighbor real quick. See if you can agree on how you would isolate t at this point. How would you get t by itself? I'll pause this real quick. If you're going to isolate t, this is just a decimal, this is just a decimal, this is just some decimal. I'm going to subtract log 46,000 from both sides. Then divide both sides here. Okay, so there's my final answer. I want you to grab a calculator and see what you get. When we worked it the other way, you guys came up with 12.38. If you're going to do this in one step in your calculator, make sure you put the entire numerator in parentheses here. Verify that you get the same answer. So 12.39. Okay. So we're just looking at rounding at that point. Same answer. Okay, let me, before we go on to 6, I said 4 is on the other recording, but here's why this is important. So, in number 4, here is here's the setup of number 4. I've worked with it already a little bit. So in number 4, you've got to take all of these parts and convert them to base 10. And then on the left-hand side, you can add these two exponents. On the right-hand side, you can add these two exponents. And then each side will be put into base 10. But you've got two pieces on the left that are multiplied, two pieces on the right that are multiplied. So they're each going to have to get converted to base 10. Then you'll add the exponents. So you'll see that in the other video, but... Okay, so number 6. Okay, number 6. If I just write log 57. Log 57 is the... Okay, good. Exponent you put on 10 to make 57. How did you know we were talking about the exponent on 10? Okay, good. So by default, it is 10. Bree? The whole back of this next. Yeah, that's what we're right now. Yep. So you guys said log 57. Well, you know, log is base 10. You don't have to write the 10 here. If you don't write the 10, by default, it's base 10. So log 57, that's the exponent you put on 10 to make 57. This guy here, which, if you can answer, I mean, now that you see that, you can probably do a better job estimating or just answering number 7. That whole idea of log base 2 of 30 is between what two whole numbers? Bree? Okay. Did you get this part? Okay. What about what does this symbol tell you to do to the number 4? The square root. Okay, so what is the square root of 4? 2. So it's a notation thing. You see that symbol, you know, okay, I need to do something to 4, and I know the answer is 2. Right? And I've kind of trained you guys on this one. I said, hey, you got this function. It's called log. Log of 57. Okay? Mm-hmm. Mm-hmm. Okay, so what you were looking at, let's say you have x to the fourth, y to the sixth. If I raise that to the 1/3, could you simplify that? No, what would you do? Somebody tell us if I said simplify it. X to the quantity x to the fourth times y to the sixth to the 1/3. Andrew? Okay. So this would be x to the 4/3, y to the second. Okay. Now, did you know it's a notation thing? You might have seen it in algebra, and maybe this is the first time you saw it, but so there you go. So just a notation thing. Now, we're talking about log. Log is by default. Log is by default base 10. By default, what number gets put in here if it's not there? Yeah, you guys are right. If there's no number there, the number there is 2, the square root. That's why the square root of xy cubed can be written as xy cubed to the 1/2. All really good questions. Okay, Natasha, then Bree. So good. No, that's a great notation question. Bree? That one? Correct. I'm not sure about the problem you're recalling. If you do come across it, just write it down. We'll do it. Okay, so we're talking about notation. We just went over 6. Log base 4 of 10. The exponent you put on 4 to get 10. So this is the exponent you put on to make. Okay. So right now you just guess and check. Yeah. Yeah. Right now I'm not telling you how to put it in your calculator. I want you to estimate it. Well, talk to me about your issue with estimating it, Andy. Okay, what's the answer? Why do you think 4 and 5? Yeah. Hold on. Shh. Okay. What do you mean for 6? Repeat that one more time. You found what in your notes? That is true. So the answer I didn't want to give Andy yet. If he applied that here. Now, I'm going to ask this style of question, and if he wants to figure out the decimal on this, what I'd really encourage you to do is say, 2 to some 2 to an unknown equals 30. Okay, 2 is 10 to the log 2. 30 is 10 to the log 30. Solve that for x, and you get x equals what divided by what? Log 30 divided by log 2. That's right. So that's how I would encourage you to solve that. If I said, what is it? Great. Okay, so 6 is a notation thing. It's the base. If the 4 being there as a subscript tells you we're looking for the exponent that goes on a base of 4 to get you 10. So 4 to the unknown equals 10. What's in that box there represents the unknown. 4 to the unknown equals 10. Log base 4 of 10. The exponent you put on 4 to get 10. What about log base 2 of 8? See if you and your neighbor agree, guys. Okay. Bree, did you get the first one? Okay. So when I give you this, you're not sure what the answer is. At this point, so the first one there, you should be able to, without a calculator, get the answer. What's the answer there? Okay. So you just ran through the computation, multiplied 4 by 2, and got 8. 4 times 2, another way to represent 4 times 2 is with 8. Another way to represent log base 2 of 8 is with the number. Well, wait, log base 2 of 8. That's the exponent you put on 2 to get 8. So log base a of b is the exponent you put on a to get b. That's what the notation means. So what was your previous understanding of log? Well, when we didn't put a number underneath it, what base were we working with? What 10? Yeah. So I don't always have to work in base 10. Well, in the one I circled, that's base A. Leslie? Okay. The exponent you put on 7 to get 7 to the 8th. Why do you want to use a calculator to answer that one? So, so what exponent do you put on 7 to end up with 7 to the 8th? Okay. Did I? Shh, hold on, hold on. You guys, you're going about this the right way. I appreciate this discussion. So, mhm. So to 6. Okay, explain what log base 4 of 10. Well, number 6 is different because it just says explain. What does this represent? It represents the exponent you put on 4 to make 10. You don't have to compute it. Yeah, 8 is another way of asking a similar question. So, or I should say, let's say looked at 9. But 8b, yeah. 8b, very similar. If you understand what a logarithm is, that it's an exponent, then 8b is pretty quick. 8a, what I have in yellow, what's in yellow is, talk me through what's in yellow. What'd you guys say? The what? Okay. Okay. Anybody know what the answer is? No. So were you okay with the description we wrote? So the exponent you put on 4 to get 15. Go ahead and put that on 4. Natasha? So as far as the translation goes from what I first highlighted in yellow to what I highlighted second, are you okay with that? Or is that where the question is? Okay. That first thing highlighted in yellow, that's what it represents. It is that exponent that when you put it on 4, you get 15. So after I erase this, I say, well, now put that exponent on 4. Well, ultimately, do you understand what I have highlighted in yellow? Do you understand what that is? It represents, I'm sorry, I'm saying it again. It represents the exponent, the number, that when you raise 4 to that number, you will get 15. Yep, yep, yep. Now, it's sort of a trick question. So I said, hey, you're thinking of a number when you raise 4 to that exponent, you get 15. So I'm saying now take that number, the number you were thinking of, the exponent you would put on 4 to make 15, and actually go ahead and put it on 4. How much do you think you're going to get? Yep. It would just be 15. So it's not a measure. It's not a computation question. It's just, do you understand what logarithms are and the notation used?